So we are now on video 11, I think. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So we're on the 11th video in my series about fractions. This is going to be on subtracting fractions and mixed numbers where the denominators are different. So the video prior to this was adding fractions and mixed numbers where the denominators were different. And that video was pretty long because we had to go over the process of finding a least common denominator and equivalent fractions. That took a little bit longer. So that video is a little long. Power through it. We go through tons and tons of examples. This video will be a bit shorter, all right, because we don't have to go through the motions of learning how to do the LCD and the equivalent fractions. So this one will be a little bit quicker, a little bit more direct, but it's going to have tons and tons of examples. And then after this video, we're going to do order of operations, and that'll be it for this series. And then we'll start a brand new series on decimals. Okay. So let's see, without further ado, to be completely cheesy, let's bring up the whiteboard. Okay. So we already know the basics for adding fractions with different denominators. It's almost identical to subtracting. So subtracting fractions. And again, in this case, we're going to be dealing with uncommon denominators. Okay. So first step, and you kind of already have this from the previous video, but I'm just going to kind of go over it a little bit, review quickly. We want to find the LCD. Remember, the LCD is the least common denominator. It is the smallest multiple your denominators have in common. And there's a couple of different ways to find it. So I'm going to show you some shortcuts, some quick tricks to remember, and then I'll show you at some point both methods for finding the LCD. Once you find the LCD, you want to get equivalent forms of all of your original fractions. So you want to rewrite your fractions so that the denominator is the LCD. So you're just getting equivalent forms of the LCD. You then subtract your numerators. And then we keep the common denominator. And the final step, no, it's kind of stupid. Let me fix that. The final step is to simplify. That's kind of a big deal. Fractions, when you're adding and subtracting, are completely different than when you're multiplying or dividing. And that's one of those things that a lot of times students will say. They'll say, I know what to do, I just don't know when to do it. If you don't know when to do it, you don't know what you're doing, okay? So you really need to learn to separate multiplication and division of fractions from adding and subtracting fractions. Multiplication and division, one of the first things you do is simplify. Addition and subtraction, it's the very last thing you do. All right, so you'll probably remember these three steps are identical to the three steps that we did in the previous video where I talked about subtracting fractions and mixed numbers with the same denominator. So we're going to take that idea and we're going to add it to this idea of finding the LCD and the equivalent fraction. So we're just kind of making two worlds collide. For the first example, we need to look at 5/6 minus 1/5. Okay. So here's one quick trick to finding the LCD, okay? If one of your denominators is prime and it is not a factor of the other denominator, the LCD is just the product of those two numbers. So if you look at 5, it's prime, and then the factors of 6 are 2 and 3, so 5 is not a factor of 6. That means that the LCD is just going to be the product of 6 times 5. So if we look at that LCD table, you can see that we're going to have 3 factors. First factor is 5. The second 2 factors are 6. So we end up with 6 times 5, or 30 as the LCD. So look for that quick trick. It's sort of like a little shortcut to the LCD. If one denominator is prime and not a factor of the second denominator, the LCD is just going to be the product of those two denominators. All right. So once you have the LCD, you want to rewrite both of your fractions. You want to find equivalent forms of those fractions. So the way we do that is we look at our denominators. What would I multiply 6 and 5/6 by to get 30? Well, I would multiply by 5, top and bottom. It's very important you multiply top and bottom. Remember, this is that weird version of 1. So what we're doing is we're multiplying 5 over 6 technically by 1. Recall from way previous videos, multiplying by 1 doesn't really do anything. All right, so we're not changing the value of 5 6. We're simply changing the appearance of 5 6. Okay, so then we do the same thing for 1/5. What do I multiply 5 by to get 30? Well, 6. So I multiply top and bottom by 6. There's my other weird version of 1. All right, now we just rewrite the whole problem. 5 times 5 is 25. 6 times 5 is 30. 1 times 6 is 6. 5 times 6 is 30. I've now got my common denominator. I subtract my numerators. 25 minus 6 is 19. Common denominator stays. And then I ask myself if this can be reduced. Okay. Do 19 and 30 have any common factors? The answer is no. So we're done. All right. Another example would be something like 5/7 minus 1/2. Now, this is another quick trick you can look for to save yourself some time and energy when it comes to finding the LCD. If both of your denominators are prime, 7 and 2 are both prime. If both of your denominators are prime, the LCD is the product of your denominators again. So here our LCD is going to be 14. So now we want to get those equivalent forms of our fractions. Okay, so looking at the 7 and 5/7, I would multiply it by 2 to get 14. So top and bottom by 2. Looking at the 2 and 1/2, I would multiply by 7 to get the LCD of 14. I rewrite the problem. 5 times 2 is 10. So I get 10/14. 1 times 7 is 7. So I get 7/14. And remember, don't reduce yet. If you reduce at this point, it's completely counterproductive and you go right back to where you started from. Now we would subtract our numerators. So 10 minus 7 is 3. Keep the common denominator and look to see if you can reduce. 3 and 14 have no common factors, so we are done. All right. Another quick trick you can look for would be, let's say we have 4/5 minus, let's see, 3/20. Now in this case, 5 is prime and it also is a factor of 20. So we have a situation here that's a little bit different than this situation right here. So we had that 5 was prime, but it was not a factor of the other denominator 6. Here it's a tiny bit different because this time 5 is prime, but it's also a factor of 20. So we don't want to multiply these two denominators. If you multiply these two denominators, you'll get a common multiple, but you won't get the least common multiple. So what we do here is we notice that 5 divides into 20 evenly. If that ever happens, your LCD is just the larger denominator. Okay, so 20 is the LCD here. So because 20 is the LCD, I don't have to rewrite 3/20. It's already got the LCD as the denominator, but I do need to rewrite 4/5. So I look at the 5 and I ask myself, how many times would 5 go into 20? Or what would I multiply 5 by to get 20? The answer is 4. All right. So I rewrite the whole problem and I get 16 over 20 minus 3 over 20. So I've got my common denominators. I subtract my numerators. 16 minus 3 is 13. Keep the common denominator. There are no common factors between 13 and 20, so I am done. That's it. So again, look for those quick tricks for your LCD. 5 goes into 20, that means 20 has to be the LCD. All right, let's look at another one like that. What if I had 37, let's do 38/14 actually, minus 5/7. Okay, now you could do this one two ways. There are two tricks for this one. The first thing you could do is you could acknowledge the fact that 7 goes directly into 14. So we could do just like we did in the previous example. We could say 14 was the LCD, okay? And then we could go from there. So let's go ahead and look at that way kind of first. So 38/14 does not need to be rewritten. 5/7, however, does. I would need to multiply top and bottom by 2. So I get 38/14 minus 10/7. Well, 38 minus 10 is 28. So I would get 28 over, whoops. It's so much better in class because you all catch these little goofs. The denominator on this fraction would be 14, not 7. Okay, so 38 minus 10 is 28. My common denominator is 14. And well, what happens? I just get 2, right? 14 goes into 28 twice. Okay, so that would be your final answer. The other way you could have approached this exact same problem, and this one is very unique. Something like this is very rarely going to happen. Now, I noticed that 7 goes into 14. Okay, so we did the whole LCD as 14. But look at this one. And again, this is something that's very, very rarely going to happen. But what would happen if I did reduce 38/14? Now, from the get-go, we've been real clear. You simplify last, okay, always. But in this one case, what does happen if I reduce? Well, 38 and 14 are divisible by 2. So I get 38 divided by 2 is what, 19? And then 14 divided by 2 is 7, right? So I rewrite the whole problem. I get 19/7 minus 5/7. What do you notice about the denominators? Oh, they're common again. So this is a weird situation where you could reduce first. This almost never happens, but you could reduce first. You get a nice little shortcut here. 19 minus 5 is 14 over 7, which is still, ta-da, 2. Okay, so this problem you could solve 2 ways. I will say it again. This right here, oh dear. This right here is rarely ever going to happen. This right here happens quite a bit. Okay, so just be on the lookout for those little shortcuts. Let's try another one. So for this one, let's say that we have 7 over 9 minus 5 over 12. Let's do 4 over 12. Well, 5 is fine. Okay, so in this particular case, I want to remind you of another way to find an LCD. So in this video so far, we've looked at all shortcuts. In the previous video, the one where we did adding, we did a lot of that LCD table. So we are going to do some LCD table in this video. The next example, for instance, we will. But for this one, I want to remind you that you can find an LCD by listing out multiples. So this one will be pretty easy because I don't have to list out that many multiples to get one that matches, but 9 times 1 is 9, times 2, times 3, times 36. I happen to kind of have 36 stuck in my head. I feel like 12 goes into 36. So let's see. 12 times 1 times 2 times 36. There you have it. We have the least common multiple. So that tells me my LCD is 36. So for me personally, I prefer the LCD table, which I will show you in the next example for sure. Okay, but I want you to remember all of the other methods too, because I want you to be presented with no scary problems. So no matter what problem is thrown your way, you have a method that you can find the LCD for. So for some examples, it's going to be really easy just to list out the multiples. This is one of those. All right, so we need to rewrite both of these fractions. 7 over 9, I need to figure out how to rewrite that where 36 is the denominator. Well, I multiply 9 by 30. I multiply 9 by 4 to get 36. I do the same thing for 7. For 5 over 12, I would multiply by 3 to get 36. So I do the same thing to the numerator. I'm going to rewrite the problem. I get 28 over 36 minus 15 over 36. I've got the common denominator now. So I subtract my numerators. And what I get here is 28 minus 15 is 13. 13 and 36 have no common factors. So we're done. All right. So you've seen lots of shortcut ways to either add or subtract those. We'll subtract for this video. The fractions, shortcuts for finding the LCD. Now let's get back to a couple of examples where we do that LCD table that we did a bunch in the video on adding. Okay. Let's look at 8 over 21 minus 3 over 28. Okay. You could certainly sit and list out multiples, but I want to remind you of how the LCD table works. Okay. So LCD table, I look at the denominators. I want to find prime factorization. So I want to find all of the factors of these denominators, and I want to get to a point where all of those factors are prime. So 7 times 3 would give me 21. Both are prime. I'm done. 4 times 7 gives me 28. 4 is not prime. I rewrite it as 2 times 2. I drop down the 7, and there's my prime factorization. I then put these in a table. So I've got a row for 21, a row for 28, a row for the LCD. I fill in one factorization. It does not matter which. Let's say I do 28. Now, what I've done here is I've created 3 columns in this table, and each column is represented by a number, and that is the only number that can go in that column. The first 2 columns can only take 2s. The third column can only take 7s. So now what I want to do is I want to line up the factors for 21, okay? And I want to make sure I line them up so that they're in a column that they can be in. If I don't have a column, I start a new one. So I notice in 27 that in 21, I have a 7. So I'm going to line that up in the 7s column. The 3 that I have right here, I cannot line up in either of the first 2 columns because those columns are designated for 2s. So I start a new column. All right. Now the value of each column, I multiply those out, and that gives me my LCD. All right. So 3 times 7 is 21. 21 times 2 is 42. 42 times 2 is 84. So my least common denominator is 84. Remember, this is the smallest number that 21 and 28 would divide into evenly. Okay. So we need to go and rewrite our original fraction. So I asked myself, what do I multiply 21 by to get 84? Or you could also say, what do I divide, or what happens when I divide 84 by 21? No matter how you word the question, you get a 4. So we multiply top and bottom by 4. We do the same thing for 28. What do I multiply 28 to get 84? 3. So top and bottom by 3. Now, multiplying out, I get 32 over 84 minus 9 over 84. All right. So 32 minus 9 is going to be what? 23 over 84. Now, 23 is prime. It does not go into 84. So this right here is your final answer. All right. Let's do another one with the LCD table. I want to make sure that we cover plenty of examples. Let's look at, how about 4/12 minus 3/16? Do I like that one? Let's do this instead. I like this one better. Same numerators, or same denominators, different numerators. Okay, so we're in a situation where we need an LCD. You could certainly list out multiples again, but I want us to practice the table because, one, I just want you to have a method no matter what. So no matter what problem you're presented with, you have a method that'll work for you. There are going to be times where the table is going to get you the LCD quickest, or it's going to be just easier for you. There are times where listing out multiples is going to work. There are times where just knowing little quick tricks are going to work. I want you to know how to do all of them. Also, when you get to higher level algebra, There are times where you do addition of what we call rational expressions. Rational expressions are fractions that contain algebra. You really need to know the LCD table for that, okay? So it's worth practicing. So we start by finding our factorizations of 12 and 16. 12 is 4 times 3. 4 is 2 times 2. Drop down the 3. There's our factorization for 12. 16 is 4 times 4. The 4's can be written as 2 times 2. So there we have it. Now we're going to fill in our table. Remember, a row for each denominator, a row for the LCD. Fill in one factorization, doesn't matter which. I'm going to start with 16. So now I've got 4 columns in this table, all of which are a 2's column. That means the only numbers that can go above these 2's would be other 2's. So I want to try to fill in as many factors from 12 as I can in the table that I already have. Anything that won't fit in the current version of the table, we add new columns. So I've got 2 2's in 12, so I can line them up anywhere in the first 4 columns. But then this 3, I cannot line it up with the 2's, so I have to start one new column. So I've got 5 columns to this table. The value of each of those columns gets multiplied, and that will tell me my LCD. So 4 times, well, let's see, 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. And then 16 times 3 is 48. Okay. So we need to rewrite the 2 original fractions where the denominator is 48. So we're looking for those equivalent forms. Okay. So 12 times 4 gives me 48. So multiply top and bottom of 7/12 by 4. 16 times 3 gives me 48. So multiply top and bottom by 3. So let's see, that gives me 28 over 48 minus 3 over 48. Well, 28 minus 3 is 25, all over the common denominator of 48. And it just so happens that 25 and 48 have no common factors, so you're done. Not too bad. All right, one more, maybe 2, and then we'll look at mixed numbers. So this time we have 5 over 6 minus 1 over 4, okay? You could either list out multiples, you could just kind of see in your head what the LCD is going to be, and hopefully you do get to that point, but it usually takes a while. Or you can do the table. So for fun, let's do the table. Now 4, I know without doing any work, is 2 times 2. 6 has factors of 2. I can line one of those up, and then factors of 3. I need a new column. So the LCD is going to be the product of the value of each of these factors. So our LCD in this case would be 12. Okay. So we rewrite each of our fractions. 6 gets multiplied by 2 to get 12. So top and bottom by 2. 4 gets multiplied by 3 to get 12. So top and bottom by 3. I rewrite. Excuse me. I get 10 12 minus 3 12 or 7 12. 10 minus 3 is 7. Keep the common denominator of 12. 7 and 12 have no common factors. So we're done. All right. Let's do maybe one more. Let's do this one. 1/6 minus 1/30. So if you were paying attention to the earlier examples, we have some quick tricks. I happen to know that 6 goes into 30 evenly. So that means without doing any work, my LCD is just going to be 30. So remember, if one of your denominators goes into the other denominator evenly, the bigger denominator is your LCD. So since 30 is the LCD, I do not have to rewrite 1/30, but I do need to rewrite 1/6. Okay. So what do I multiply 6 by to get 30? Well, 5. So cleaning everything up, I get 5 over 30 minus 1 over 30. So 5 minus 1 is 4. So I get 4/30. I need to look to see if I can reduce. And in this case, I can reduce. 4 and 30 have a 2 in common. 4 divided by 2 is 2. 30 divided by 2 is 15. So our final answer is 2/15. And that's it. All right. So let's do just a really quick recap. Subtracting fractions with different denominators, you find the LCD. You look for equivalent fractions. Using the LCD, you subtract your numerators. You keep the common denominator. You simplify last. We did do one really bizarre, very uncommon exception to the simplify last, but otherwise you simplify last. So we looked at some quick tricks for finding the LCD. So in the first example, we had denominators of 5 and 6. 5 is prime. It is not a factor of 6, so you just multiply those two denominators to get 30. No need for the table. For the second example, both of our denominators were prime. If ever your denominators are both prime, you just multiply them to get the LCD. No table needed. All right. We had an example where one denominator went into the other denominator evenly. 5 goes into 40, or 5 goes into 20 rather. So 20 is just the LCD. And then we had other situations where we either listed out the multiples or we used the LCD table. Okay. So that leads us to mixed numbers. Now recall, I like to keep mixed number format when adding and subtracting. So I mentioned this earlier in the video. When you are dealing with fractions in particular, you really need to know what to do when, and students tell me all the time, I know what to do, I just don't know when to do it. That means you don't know what you're doing. So you have to really separate multiplication and division from addition and subtraction. They're never going to be the same. So things that work for multiplication and division aren't really going to work for addition and subtraction. And one thing that really comes up with mixed numbers is when you're multiplying and dividing mixed numbers, you have to convert them to improper fractions before you do your multiplication and division. With addition and subtraction, it's optional. So you certainly could convert your mixed numbers to improper fractions and then do your adding or subtracting, but I do not like to do that because I find with addition, you get these gigantic numerators that are, one, it's a little bit difficult to find the improper fraction. Then adding and subtracting just becomes more complicated because sometimes you're adding or subtracting 3 and 4 digit numbers, and then it's hard to reduce, it's hard to convert back to a mixed number. So for me, I keep things looking like mixed numbers. Okay. Now the weird thing that shows up with subtraction would be borrowing. So let's do an example where we have the same denominator. So this is something like we did in a couple of videos prior, but I want you to see it where you have the same denominator to remind you of how to borrow. So again, this is in the video on subtracting fractions and mixed numbers with the same denominator. This is just kind of a review. So we're going to review borrowing. All right. So let's say we have 10 and 4/7 minus 5 and 6/7. Now you can see we have common denominators, so that tells us we would go ahead and subtract our numerators, but the problem is I cannot take 6 from 4. 4 is smaller than 6, and that's a problem, so I have to borrow. We borrow 1 from the 10, making it a 9, and that 1 that I borrow, I'm going to add it to the 4/7, and I'm going to have it written in fraction form using the denominator that I already have. So I already know that my common denominator is 7. So I need a fraction that has a value of 1 and a 7 as the denominator. That's just going to be 7/7. So cleaning this up a bit, we have 9 instead of 10 now. And then I add the 4/7 and the 7/7. That does give me 11/7. Don't sweat the fact that this is improper yet. It gets worked out in the wash. So I can now subtract 5 and 6/7. So 6 can be taken away from 11. Now I get 5 over 7. And then 9 minus 5 is 4. All right, so just keep that in mind as we start borrowing, because these problems are going to be a little more, they're not harder, they just have more steps and it gets a little messier. So just be neat and organized and remember this, remember how to borrow. Okay, so let's do a few examples. Trying to find a good one. I think I'm good on both of those. How about this? We have 38 and 2/3 And from that, I want to subtract 25 and 13 sixteenths. Okay, so this one we have denominators of 3 and 16. So the very first thing I want to do is I want to rewrite these mixed numbers, forcing the fractions to have common denominators. Okay, so let's look at the denominators. We have 3, we have 16. Now remember those shortcuts that I told you earlier. If one of your denominators is prime and it is not a factor of the other denominator, then just multiply the two denominators. So 3 is prime. 3 is not a factor of 16, so all I do is multiply these out, and I get that my LCD is 48. Okay? So we're going to rewrite both of the fractions in the mixed numbers so that their denominators are 48. Okay? So 3, I would multiply by 16. So top and bottom by 16. 16, I would multiply by 3. So top and bottom by 3. All right, we're going to clean this up a little bit. We get 38 and 32 48ths minus 25 and 39 48ths. Okay? So now we have common denominators and we would want to subtract. The issue is I cannot take 39 from 32. 39 is too big, so I borrow. I borrow 1 from the 38, making it a 37. The 1 that I borrow, I'm adding right in here to this fraction, and I'm going to write it to where it has a value of 1 and a denominator of 48. The way we make that happen is we add it in as 48 over 48. Let's clean things up again. All right, so my first mixed number is now 37, and then I add 32 and 48. If you need to do some side work, don't sweat it. 8 and 2 is 10, carry a 1. 4 plus 3 plus 1 is 80. So this is really 37 and 80 over 48. Don't get hung up on the fact that this is improper. This is going to be improper for just a few seconds. We're getting ready to fix it. Now we can subtract 25 and 39 48ths. If you need to do some side work, do it. All right. Cool. So do your side work. We get 41 over 48. 37 minus 25, I get 12. And there you have it. We get 12 and 41 48ths. And that's it. I say that's it like this is a piece of cake. It's not the easiest thing ever. It's messy. I think that's the big thing about this right here is it gets a little messy. But imagine how difficult this would be to do if you converted to improper fractions. Okay, so just for the sake of fun, let's convert to improper fractions and then worry about finding an LCD. So 38 and 2/3 would be 38 times 3 plus 2. We would get 116 thirds minus 25 times 16 plus 13. We would get 413 16th. We already know the LCD is 48, so I'd multiply top and bottom of the first fraction by 16, second fraction by 3. So let's see, 116 times 16, we get 1856 over 48. 413 times 3, we get 1239. And I've used a calculator for all of this, okay? Now 1856 minus 1239, we get 617 over 48. We then would have to take the steps to convert that to a mixed number. I just don't like this method, okay? It works, but your numbers just end up being so big, all right? So even though this method looks a little daunting at first, to me, you're dealing with smaller numbers and it's just easier to work with, okay? Let's practice some more. Let's look at 12 and 2/9. Let me go back to black ink. So let's say we have 12 and 2/9, and from that we want to subtract 6 and 5/6. Okay. Gotta get a little sip of water. Okay. So as far as the LCD goes, you could list multiples, you could do the table. Some of you just kind of see in your head what this is going to be. Let's say for this example, we kind of quickly list multiples. So 6 times 1 times 2 times 3, I already see what it's going to be. 18 times, or 9 times 1, 9 times 2. Our LCD is 18. Okay. So we want to rewrite each of these fractions so that the denominator is the LCD of 18. So for 9, I multiply top and bottom by 2. For 6, I multiply top and bottom by 3. So I get 4/18 and 15/18. So I'm going to clean up the whole problem. So I have 12 and 4/18 minus 6 and 15/18. And I think you all can see here that we're in a situation where we have to borrow again. I cannot take 15 from 4. So I'm going to borrow 1 whole from 12. That makes it 11. And the one that I borrow has to have a value of 1, obviously, and it has to have a denominator of 18. The way we make that happen is we write it as 18/18. We clean up. I get 11, and then I want to add 4/18 and 18/18. That gives me 22/18. Again, don't sweat the fact that it's improper. It's only going to be improper for a minute. Now I can subtract. I can take 15 from 22. In fact, 22 minus 15 is 7. So I get 7/18. And then 11 minus 6 is 5. 7 and 18 have no common factors. So our final answer is 5 and 7/18. It's not too bad, right? Let's try another one. Trying to keep track of the ones I'm doing. How about this one? 15 and 5/16 minus 6 and 3/8. So this problem does have one of those shortcuts for the LCD. If I look at 8, it will go into 16 evenly. So I could say that the LCD is just the larger denominator. The LCD is 16. Okay. So I don't need to rewrite 5/16, but I do need to rewrite 3/8 so that the denominator is 16. I would multiply 8 by 2, so top and bottom by 2, and I get a 6. So I'm going to clean things up. I've got 15 and 5/16 minus 6 and 6/16. And you can see here, we're in a situation where we definitely need to borrow. I cannot take 6 from 5. So I borrow 1 from the 15. I add it right back in as a fraction, and I'm going to have it as 16/16. 16 because that's the common denominator, and the only way to get a fraction that equals 1, where 16 is the denominator, would be to write it as 16/16. So I clean up. I get 14, and then I want to add 5/16 and 16/16. That gives me 21/16. From that, I want to subtract 6 and 6/16. Well, 21 minus 6 is 15. 14 minus 6 is 8. 15 and 16 have no common factors, so we are done. Not bad. Let's do one, maybe 2 more. How about 17 and 7/25 minus 9 and 7/20? All right. So this is one where the table or listing out multiples would be about the same amount of work. So let's look at multiples. So I get 20, 40, 60, 80, 100. I feel good about 100. So 25, 50, 75, 100. Bingo, we've got our LCD. Okay. So I want to rewrite both of these fractions so that the denominator is 100. All right. So if I look at 25, I multiply top and bottom by 4. 20, I would multiply top and bottom by 5. So I get 28 and 35. So let's clean up. I now have 17 and 28 hundredths minus 9 and 35 hundredths. So I think at this point you can see that we need to borrow. I cannot take 35 from 28. I borrow 1 from the 17. And then the 1 that I borrow, I add it right back in as 100 over 100. I clean up again. This time I have 16 and 128 over 100. Again, don't sweat the fact that that's improper. It's going to get fixed just in a second. Okay. If you need to do a little side work, do some side work. There's no shame in it. 135 minus, or 128 minus 35. 8 minus 5 is 3. 12 minus 3 is 9. So when we subtract, we get 93 over 100. 16 minus 9 is 7. And there you have it. All right. So just keep rewriting the problem. Do a step, kind of clean it up. Do a step, clean it up, and it's not that bad at all. Let's do one more. Keep track of the ones I've done. How about this one? 13 and 2/15 minus 7 and 2/9. Plug up my computer before it dies. Okay, so here's one where you could list out multiples. You could do the table. Let's just practice the table one more time. So 9 would be 3 times 3. 25 would be 5 times 5. You can see that no factors are in common. So we really just end up getting the product of the, oh, wait a minute. Bless my heart. I've been doing this a lot the last few days. We're not dealing with a denominator of 25. We're dealing with a denominator of 15. Please excuse that. 3 and 5. So you do have factors that overlap. So the table is going to work. So I get 3 times 3 times 5. So it looks like our LCD here is going to be 45. You need to excuse that whole 25 thing. If I wasn't so far into the video, I would just stop and start over, but not right now. Okay, so we need to rewrite both of our original fractions so that the denominator is 45. All right, so for 15, I would multiply by 3, so top and bottom by 3. 9, I would multiply by 5, so top and bottom by 5. All right, so let's see, I get 6/45 and 10/45. Let's clean up the whole problem. I have 13 and 6/45 minus 7 and 10/45. You can see at this point, we really are going to have to borrow. I cannot take 10 from 6. So I borrow 1 from the 13. The 1 gets added right back in as a fraction. The fraction has to have a value of 1 and a denominator of 45. So we get 45/45. Clean it up again. I get 12. And then I'm going to add 6/45 and 45/45. So I get 51/45. Don't sweat the improper situation. It's going to work out in just a second. All right. So 51/45 minus 10/45 is going to be 41/45. 12 minus 7 is 5. 41 and 45 have no common factors, so you're done. All right. Okay. Hopefully that helps you a bit with adding and subtracting fractions. So the last 4 videos have all been on adding and subtracting fractions. The first video was adding fractions and mixed numbers where you had common denominators. The second video was subtracting fractions and mixed numbers with common denominators. And then the third video was adding mixed numbers and fractions with different denominators. This one was, of course, subtracting fractions and mixed numbers with different denominators. Practice it. Okay, generally when people say they don't like fractions, they're talking about adding and subtracting. Okay, it's not the hardest thing in the world. You need to practice each step. Make sure you're really good at each step before you kind of bring it all together. But at the end of the day, just work out those problems. Okay, last video in the series is coming up and it's going to be on order of operations. All right, take care.